Hi, I'm going to be explaining this 2 gene problem from chapter 3, number 16. Let's go through it. So the prompt states that Mendel crossed peas having round green seeds with peas having wrinkled yellow seeds. And all the F1 plants that had seeds, that were round and yellow, meaning that this round and yellow are dominant traits. And it's asking us to predict the results of a test crossing these F1 plants. And so what I did here was kind of go through the prompt that they gave us. So on the top right here that has the big W, little y, that's being crossed with the little w, big Y are the parents, right? And so on this part here that says F1 crosses, it's really supposed to say parent crossings, but that's my mistake. And so when we do these crossings, it's important to know that these are being equally segregated and have an independent assortment, which is why there's one Punnett square for the round trait or wrinkled trait, and then there's another Punnett square for either being yellow or green. What does this Punnett square mean? It means that when we're doing the crosses of the parent, that's why on the top there's big W representing one parent, and then little w representing the other parent. This future P child, right? This P child has an equal amount of a chance of getting either big W or little w. It seems very boring, but on the F2 crosses, or F1 crosses actually, this is where it gets spicy, but these parent or the F1s have an equal amount of chance of getting those final results, which is either big W, little w. They can only get that, right? And it's the same thing for the yellow green trait, which is represented using big Y, little y. And so once we do these crosses, which are independently assorted, we end up having F1s that are big W, and big Y, little y for all F1s, which is stated in the prompt, which shows that the round trait is dominant, and that the yellow is also dominant over the green. And so it's asking us to take these F1s and cross them with each other. And so we do the same thing again as we did with the parents. We take 2 P's and we're using a Punnett square to cross them, right? And it's the same thing that they're being equally segregated and have independent assortment, which is showing that this is where the fun stuff is. So these F2s that are coming, they have an equal amount of chance of either getting big W or little w from one parent and big W, little w from the other parent. And same thing with the green and yellow trait. So they have an equal amount of chance of getting either the yellow, big Y trait, or the little y, which is green. And so when these F1s are crossed, we end up getting 9/16 of round yellow, 3/16 of round green, and 3/16 wrinkled yellow, and 1/4 of wrinkled green. And how does this happen? Why is it 16 and all of that fun stuff? Because within the Punnett square, whenever there's a big W, that phenotype is going to overpower the other one, no matter if it's a big W or little w. And so over here, we have a 3/4 because of that. So that's why there's also a big W with the line, because if it's a big W or little w, it doesn't change the fact that this first big W is going to overpower it, showing the round trait. And so these lines over here are showing that it's independently assorted from the yellow-green trait, which is also 3/4 and 1/4 of the Y with the line and little y. And same thing down here with this 1/4. There's only one out of the 4 is little w, which is going to show wrinkled. And then it's independently assorted from the green, yellow trait. And so there's 3/4 of big Y something, and then 1/4 of little y. and you multiply them across because they're equally segregated. And so when you multiply it across, we get 9/16. So these F2s are most likely 9 out of 16 chances are going to be round yellow in comparison to the wrinkled green, which is only going to be 1 out of 16. And so here is the gene problem from chapter 3, number 16.